If you fill a glass with room temperature tap water and leave it undisturbed for a few hours, you will eventually notice that tiny bubbles begin to appear along the inside of the glass. But why does this happen? Water from the tap passes through pipes before reaching large storage tanks. The water in the pipes is under higher pressure than normal and is also at a cooler temperature. These two conditions are ideal for dissolving certain gases that are abundant in our atmosphere, such as nitrogen and oxygen. Gases are generally more soluble in water at lower temperatures, meaning that the solubility of gases in water decreases as the water temperature rises. The downward trend of gaseous solubility with increasing temperature is quite similar to how vapor pressure increases with temperature. You see, more gas molecules are dissolved in water when it's cold, but when water starts warming up, the kinetic energy of the gas molecules also increases. This allows those molecules to move more freely and break the intermolecular bonds that hold them together, thus escaping from the solution. That's why the solubility of gases decreases as the temperature rises. The temperature dependence of gases' solubility in water directly impacts the lives of aquatic organisms. As you likely know, aquatic organisms like fish need oxygen for survival, and they get it from the water they live in by absorbing the dissolved oxygen in the water through their gills. As oxygen is more soluble in colder waters, the temperature mustn't rise above a certain limit, or there won't be enough oxygen for the fish to take in. Unfortunately, that is precisely what's happening these days, largely because of human activity. Power plants, for example, discharge huge amounts of hot water into large bodies of water, which then raises the water temperature and drastically affects aquatic life. The solubility of gases in water also increases with an increase in pressure. Although liquids and solids exhibit practically no solubility change with a change in the pressure of water, gases do. It has been observed that gases are more soluble in water at higher pressures. Carbonated drinks are excellent examples of this phenomenon. The simplest way to explain this dependence is that, as pressure increases, gas molecules are forced into the solution to relieve the applied pressure. Due to the two physical phenomena described above, tap water is a good candidate, if not an ideal one, for holding dissolved atmospheric gases. However, when this water is poured into a glass and left at room temperature for a few hours, the atmospheric pressure begins to drop as its temperature begins to rise. As a result, the dissolved gases in the water escape from the solution and form bubbles on the rough areas inside the glass. As the temperature of water doesn't change very quickly, it takes a few hours for the bubbles to appear on the glass.